Alright, so in this video, we're going to be going through sample question 69 from the Society of Actuaries ExamP list of sample questions. So the question reads, the time to failure of a component in an electronic device has an exponential distribution with median of 4 hours. We need to calculate the probability that the component will work without failing for at least 5 hours. Okay, now this seems to me like the easiest question you could potentially get. All right, all this requires you to do is, understand basic probability concepts of CDF and stuff like that and expected value. But this just needs you to know information about an exponential distribution. So what is a median? A median is the value that causes the CDF of a distribution function to be equal to 0.5. So what is the CDF of an exponential? There's a really nice, clean formula. The CDF, uppercase F of x, is equal to 1 minus e raised to the negative x over theta. And what is theta? Well, theta is your expected value. And we actually don't know what it is right now, right? But we're told the median is 4. So if the median is 4, that means, sorry about that. I think I just apologized to a camera stand, phone stand. If the median is 4, that means 4 causes the CDF to be 0.5. So let me plug in those pieces of information. 0.5 is equal to 1 minus e raised to the negative 4 over theta. Yeah. Now, we're going to solve for what theta is because we're going to need that in order to calculate any sort of probability. Now, I'll just subtract 1 to both sides, right? This will become negative 0.5, and then I'll multiply the negative over to the other side. So I still end up with 0.5 is equal to e to the negative 4 over theta. At this point, this is just algebra. I'm really hoping you're super comfortable with algebra. It's key, especially for ExamFM. You're an expert algebra person, you're going to kill that one. Anyways, probability, though, is the test we're working on now. Take the natural log to both sides. So ln of 0.5 is equal to negative 4 over theta. And I'm going to want to move stuff around, and I'll have theta is equal to negative 4 over the natural log of 0.5. And I will get theta to be, well, just 1 second. I will get theta to be natural log 0.5. Just making sure I have this correct. So theta is equal to 5.77. Where do I want to start? Yeah, I'll keep it at 5.77. Seems like a nice place to round. I'm almost a little bit arbitrary with where I round off to, just, enough. Now, from here, now that we found what theta is, the expected value, we want to calculate the probability that the component will work without failing. So let x denote the hours a component will work without failing for at least 5 hours, right? It's got to be greater than 5. This is the same thing as 1 minus the complement, the probability that 1 minus the probability that x works for less than 5 hours. Now, some people might tell you could just typically what you would do is you would have the PDF and you would need to integrate, but we have the CDF already. We have a formula for that. So let me plug that in, right? Because this is a CDF. 1 minus, it's going to be, in parentheses, 1 minus e raised to the negative 5 divided by 5.77. Now I'm just writing 5.77. I have that number stored in my calculator, the longer 5.7708. That's the number that I'm going to actually end up using. Okay. And let me just take care of that. 1 minus 1 minus e raised to the negative 5 and that equals, okay, 0.42, right? And it's approximately 0.42. I'm gonna round it to 2 decimal places because that's what the answer rounds it to. It's answer choice D. Okay, so super simple, straightforward problem. You obviously need to know basic stuff about what a median is, what an expected value is, but this question only really needed you to know the CDF formula for an exponential random variable. And that's it. Nothing really to go through. Here, it gave us the median. I used the median to find what theta is because I needed theta in order to find this CDF of 5. However, the question asks for the probability of our random variable x, which is the probability of a component failing, which is the event of a component failing. So I took the complement of that, and I got 0.42. Nothing to it other than that. If there's any questions you might have, throw it down in the comments. I will answer them to the best of my abilities. I want to see more problems like this. I got a playlist, rapidly growing, I hope. Kind of inconsistent with uploads. And if this video helped you out, hit the like button, subscribe. That totally helps me out. But other than that, good luck.